collapse of precast segmental bridges during construction to be delivered by Engineer V.N. Hegde Garu. We are very fortunate to have stalwarts of eminent personality like Engineer V.N. Hegde Garu, and we thank him for sparing his valuable time to be amidst this important virtual event. I am glad to inform that the Telangana State Center of the Institution of Engineers has been regularly organizing 17 endowment lectures every year on the birthdays in the honor of eminent engineers like Engineer V. Subbarao, Engineer M. Tirupati Reddy, Dr. J. Purushottam, Engineer Koka Krishna Mohan Rao, Engineer J. V. Subbarao, Engineer T. Hanumantarao, Engineer A. P. Ranganatha Swami, Professor S. Raghavachari, Dr. Narla Tatarao, Engineer Matur Gopal Rao, Engineer Gurram Kotireddy, Engineer Atluri Venkateshwar Rao, Engineer R.L. Raju, Dr. N.V. R.L. N. Rao, Engineer M.L. Swami, Engineer L. Venkat Iyer, and Engineer K.V. Srinivas Rao, Dr. A. Ramakrishna, and Engineer I. Baswaraju. The endowment lectures are being delivered by people of eminence with considerable professional experience to throw lights on important emerging topics of today's relevance. I say a few words about Dr. A. Ramakrishna Garu for information of the elite. Was born on December 20, 1939 at Punadipadu, Andhra Pradesh. He obtained his bachelor's degree in civil engineering in 1960 from the Andhra University and MSc in structural engineering in 1961 from College of Engineering, Gindi, Chennai. He started his career in 1962 with Engineering Construction Corporation Limited, popularly known as ECC, the then a wholly owned subsidiary of Larsen and Turbo Limited. The ECC was subsequently amalgamated with the parent company and is widely known as ECC Construction Division of L&T. Dr. A. Ramakrishna, former Deputy Managing Director and President, ECC L&T. Dr. Ramakrishna, an acknowledged expert in the construction industry, known for introducing novel systems and processes, and played a central role in evolving policies relating to construction sector. He has been the president of Indian National Academy of Engineering, vice chairman of Construction Industry Development Council, CIDC, and vice chairman of National Academy of Construction. He was an independent director in few companies. Dr. A. Ramakrishna was awarded the 207 Hasib Sabbaga Award for Engineering Construction Excellence and an initiation of Engineer G.L. Rao FIE donated the award amount of 4 lakhs to IEI AP State Center to Institute Young Engineer of Excellence in Structural Engineering Area and Style L&T Dr. A. Ramakrishna Young Engineer Award to be presented every year during the Engineers Day celebrations. Due to the demise of Dr. A. Ramakrishna during the year 2013, it is proposed by the State Center Committee to organize an endowment lecture every year, that is 21st December. Since you are anxiously awaiting to hear the talk from our eminent speaker, I am limiting myself and hope that you will really enjoy his talk. Lastly, on behalf of the Telangana State Center of the Institution of Engineers, India, and on my own behalf, I once again extend a hearty welcome to all of you to this important event. Thank you, one and all. Before I request today's chief guest and speaker, I request Dr. S.P. Anchuri, FIE Core Committee member and IEI Telangana State Center and convener of the event, to introduce today's chief guest and the speaker, Engineer V. Hegde Sab. Mr. Anchuri, kindly go ahead, sir.
Thank you. In fact, it's a great pleasure to introduce my internationally known national friend, engineer V.N. Hegde. In fact, when we met in World of Concrete, Innovative World of Concrete, we had about a decade back. I thought he is from some other country because of his looks and all, but he's a true Indian. So anyway, Engineer V.N. Hegde, the former CEO of Stoop and former Executive Director of Gammons, has over 3.5 decades of experience in construction sector in the areas of design management, technical management, site management, project management, and contract management of highways, bridges, and energy structures, environmental and marine and hydraulic structures, in addition to consulting to all types of consultancies all over the civil engineering across sectors, and as a CEO is well known. And he is a recipient of more than 10 national recognitions in addition to international prizes from various institutions. And he has more than 160 publications to his credit, and is a member of Indian Road Congress, Bureau of Indian Standards Committees, and apart from being an on technical board of Indian Concrete Institute, and in fact, academic board of Sardar Patel College of Engineering and Mahendra Tech University. He's also a fellow of Indian National Academy of Engineering. And he's on the national editorial boards of Structural Concrete Journal of FIB, and also Bridge and Structural Engineers, the Journal of INJ IABSC. He has been a peer reviewer of FIB and IABSC conferences, and in addition to the journals published in the IRC, ICJ, and FIB. He's going to deliver a popular lecture by Telangana State's Institution of Engineers, India, Dr. A. Ramakrishna, 9th Endowment lecture, which will be on avoidance of collapse of precast segmental bridges during the construction. Over to Mr. Hegde.
Thank you. Thank you very much, Dr. Anchuri, and also the respected Mr. Bhimareddy on the dais, and other esteemed people on the virtual dais. I should say it's not possible for me to address as a physical dais. My voice is audible, right?
Yeah, your voice is audible, and this is live on YouTube also. So there are so many people, those who are not seen here, but they are on YouTube. Thank you. Go ahead.
Fine. Thank you very much for that nice introduction, Dr. Anchuri. And in fact, it's a great honor and privilege to have been invited to give this esteemed person's endowment lecture today, Dr. Ramakrishna. I also used to know Dr. Ramakrishna very well from L&T, and I was working in Gammon, and he was working in our sort of a competitive organization, but still in a various forums as well as the conferences, we used to meet quite often, and we used to interact with each other. So it's a privilege and honor to be delivering this lecture today, his 9th endowment lecture. In fact, I've chosen this topic today. The topic is avoidance of collapse of precast segmental bridges during construction. At a very short notice, in fact, I was told to deliver this lecture yesterday, but I was wondering what topic to be chosen. But I knew Dr. Ramakrishna was a very strong proponent of the precast construction, and he had brought out a document on behalf of the Indian Concrete Institute also on the precast construction. So I have chosen a topic today on the precast segmental technology. That is the reason behind choosing this particular topic, and I have chosen this topic today. And my contents of the presentation is basically it's for avoidance of the collapse of the precast segmental construction, which has been happening quite rampant these days all across the country. And the organization of my presentation is going to be as it's on the screen, as you can see here: understanding designs and drawings in the context of the failures during construction, and casting of the segments, including handling, stacking, and transportation, erection of the segments. And precast segmental construction is nothing but all about the joints and the temporary priestessing. So I'll be talking about the pre-stressing as well as the joint systems also, in addition to the post-tensioning as well as the grouting aspect. As we have been talking about this, the collapses which has been taking place in this country, if you really look at the collapses has happening continuously in the bridge. This is one of the bridges where during the construction of the cantilever pier, as you can see here, it's around 9.25 meter cantilever pier. During the concreting of this pier collapsed. As you can see here, the twist can be easily seen this. And that was in November, but in October again, that is 1 month previous to that, there was the collapse of bridge during the construction in Nagpur, as you can see here. Prior to that, just near to in BKC, to very close to my house, in September, the bridge was overturned. As you can see here, it's a curved tub box girder. Of course, it is not a Prica segmental construction, but it's a box girder of the steel box girder during the construction, which has collapsed. The point I'm trying to make here is every month, September, October, November, the collapse has been taking place. If you really look at the history of the collapses, bridge collapses, which has been taking place in India, and the study has been done by the CSIR, and from 1977 to 2017, they have compiled the data of the bridge collapses which has been taking place in India. And during that period, it has been reported that 6.12% of the collapses of the bridges has happened during the construction, basically. Out of the, there are various reasons, during the surveys, because of the natural disasters, so many other reasons are there. And out of which 107 bridges, out of the 123 bridges they have studied during the construction period, 107 bridges are that of the RCC as well as the Priestess concrete, as you can see here. That is the data. And the bridge collapses didn't stop there. It continued, as you can see here. And but 2017 onwards, 2018 onwards, unabated bridge collapses which has been taking place, the Prica segmental construction, as you can see here. These are all the Prica segmental construction. During the construction, the collapses have been taking place, mishaps have been taking place. Some of them are collapses, some of them are mishaps. Mishaps in the sense, as you can see here, during the pre-stressing which is taking place over here, there is an upward deflection. That sort of thing is happening over here. You can see that. So it is all in the Prica segmental construction. That too, if you really look at it, majority of them are in the spine and wing construction, for which I'll come to that later. As late as like 28 March 2021, a collapse in Dwarka flyover took place, and it was captured on the CCTV very dramatically. I want all the audience who have been participating here just to have a look at this a very dramatic collapse on the screen. Just have a look at it. Just have a look at it. It is captured on the CCTV. Just have a look at it. There is a dog which was resting on the heap of the sand, which ran to its safety. Meanwhile, also the traveler, he was just passing by. I think he was just saved because he had just passed before that. Again, you can just have a look at it. This is an interesting capture if you really have a look at it. This I'm going to show a couple of times to demonstrate why this collapse would have taken place later. This is an interesting, this one, yeah. So the bridge collapses has been taking place. Let us understand the reasons for this, and let us try to diagnose the reasons for these collapses. I will take you back to this 1958. All of you are aware that Dr. Fritz Leonhardt is one of the evergreen authorities in the design and construction of the Priestess concrete. He was a strong proponent of the Priestess concrete technology. Way back in 1958, in his classical book, he came out with the 10 commandments for the Priestess concrete engineer. In fact, if we just adopt these 10 commandments, or if you just take this precautionary notes which has been given, way back in 1958, I think would be able to stop most of the collapses which are taking place during the construction, in my opinion. Out of these 10 commandments, the 5 of them is for the designers, and the five rest of the 5 of them are for the basically for the construction people who are working at the site. I think this 10 commandments has never been as relevant as today, in my opinion. What are the 5 commandments which are specified for the designers? Priestessing means compression. Compression can take place only where the shortening is possible. So it's always, you'll have to make sure it is free to shorten in the direction of the priestessing. No restraint or no constraint is there. That's what you'll have to make. And I'll demonstrate that this particular point is so important when you are talking about the collapses of the priestess concrete bridges. Any change in the tendon radial direction produces radial forces when the tendon is tensed. Naturally, when the bar is in curvature, that when it is stressed, whether it's a reinforcement bar or a priestessing steel, there will be a radial forces during the design which has to be taken care of. Otherwise, the lamination of the concrete, which is outside the concave surface of the radial forces will take place. High permissible compressive stresses must not be fully utilized at all. Again, it's very, very relevant. I'm just going to show that. And also choose the cross-sectional dimension of the concrete, especially at the tendons, in such a way that the member can be properly concreted. If the members are not properly concreted, when the priestessing force is applied, it's going to fail. It is going to lead to the mishaps. Do not trust the tensile strength of the concrete, because a tensile strength of the concrete is especially when you are going to subject the priestessing concrete members to the compression, do not trust the tensile. Always make sure the member is under the tension condition, especially under the serviceability limit stage during the service. And transfer to the priestessing direction, especially when there is a compression is there, or normally provide the reinforcement. He is talking about the anchorage zones where the priestessing is just applied. When the priestessing is applied, there is a heavy compression as a point load over there in the transverse direction, but the orthogonal direction to that of the application of the priestessing, you will have to make sure that the radial or the spiral reinforcement and other necessary reinforcements are there. That's what he was talking about. He also gives 5 commandments to this site engineers. The priestessing steel is not like a reinforcement steel. It has a high carbon content, as well as such the ductility of the reinforcement is very less. And also it is high because of the high carbon content, sensitive to rusting, notches, kinks, as well as the heat. That is the reason normally it is always specified or warned that it should be never be, like brought near the heating any of the devices. Position the tendons very accurately, securely, and immovably. During the concreting, if it's not positioned properly, the position of the tendons get displaced. Because of that, the eccentricities which has been calculated during the design will not be valid anymore. And there could be the stresses, additional stresses in inducing the tension as well as the cracks that has to be taken care of. Concrete can everywhere be properly vibrated. That is how the concreting has to be done. That is how the reinforcement detailing has to be done. And the concrete mix has to be set that it is possible to be vibrated, and also it goes to the each and every nook and corner of the shattering mold. That has to be ensured. For any reason, there is a honeycombing and other things are there. When it is subjected to the priestessing, it's going to be crushed basically. That needs to be kept in mind. Check the structure can move in the shorten freely in the direction of the tensioning. That's what I explained earlier. That's what he has said. The highest stresses in the concrete usually occur during the tensioning of the tendons. That needs to be kept. And especially nowadays, when you're using for the full transfer of the priestess, at one stage full transfer of the priestess, you will have to be very careful and make sure that at the time of the full transfer of the priestess, highest stresses are there. And we should make sure that it is not subjected to straight to the limits of the permissible stresses when the full transfer of the priestess doesn't take place. Do not start grouting. the tendons until you have checked that the ducts are not free from the obstruction. So this 10 commandments, 5 for the designers, 5 for the site engineers, if it is religiously followed on the design office as well as the site office, I don't think the collapses as mishaps can happen anymore. Now coming to the precast segmental construction, it has some of the commonalities, like it has common features are there. As you are aware, the segments are cast at a casting yard, brought to the location, erected into the location, as you can see here. Then it is post-tensioned together and it is made self-sustained. And after having made that, the girder moves to the next location and it continues. So basically, the precast segments are cast somewhere. It has to be stacked. It has to be brought to the location where it has to be translated into the reality. That there has to be an erection method. That is how it happened. And most of the failures which has taken place happened because of the span by span method of erection. While span by span method of erection was going on, the failures have happened. Also, the cantilever method of erection for the precast segmental construction is going on for many of the extrudos bridges. I don't see a failure which has been taking place over there. And in most of the cases, it's always the one-stage priestessing. At the full transfer of the priestess, it was subjected to only one-stage priestessing. Normally, earlier days, we used to go for the multiple stage priestessing, first stage priestessing as well as the second stage priestessing. But in most of these cases where the failures have taken place was one stage priestessing at the full transfer of priestess. And also they were all invariably, in majority of the cases, were the spine and wing construction. I'll explain what it is. And it's always the internal priestessing with the epoxy glued joints. And I'll come to that, the external priestessing as well as the internal priestessing, how external priestessing is better, and also the how dry joints are better later. And most of the failures are the compression failures, as I'm going to demonstrate it. And the design is always done by the beam analogy. When I say design is done by the beam analogy, this is not done by the finite element method. The beams are considered to be, the span is considered to be a beam, irrespective of the width of the beam. And it has been considered beam as a beam, and the beam analogy has been done. That is what the beams has taken place. All of you are aware why the precast construction is normally adopted. I don't want to get into the benefits of the precast construction. Everybody is aware of this, why it has been done. Though it is a detour from the today's presentation, I just want to tell you that the precast segmental construction in India started way back in 1971 and 72. It was first time adopted for the Krishna Bridge at Deodur. In fact, as far as the precast segmental construction is concerned in India, it was the turning point in the history of precast segmental construction in India. It's very interesting to compare when the precast segmental constructions also started in United States, almost started 10 years back, later in the United States. But for this key bridge, they seem to have adopted the dry joint with the epoxy, the dry joint with the external priestessing. Here it is very ingeniously done in the Krishna Bridge Deodur. Nowadays, we are all aware the segments are cast horizontally, one after the other, whether it's a long line method of casting or a short line method of casting. But here in the first precast segmental bridge, which was done in Krishna Bridge at Deodur, as you can see here, the segments were caught vertically. That is to make sure that the segments are match cast, and the ease of the construction was perceived to be for the vertical way of casting like this. That's why it was done. It's very interesting to note that. As the deck width went on increasing, traffic lanes went on increasing. Earlier, in this particular case, the Krishna Bridge at Deodur, width of the deck was around 5.5 meter. But we had to cater for the 2 lanes to 3 lanes, 3 lanes to 4 lanes, 4 lanes to 6 lanes, and from 6 lanes to 8 lanes these days. As the lanes requirement went on increasing, and also it was always felt that to make use of the space under the box girder or a girder on top deck, and also to have the less repetition of the operation, it was preferred to have a single piers. On the single piers, we need to have a deck whose lanes requirement kept on increasing. It was a single box girder of various types, as you can see here. Trapezoidal step, it's a single box girder, single cell box. As the lanes went on increasing, we went for the strutted box as well as the multi-cell box. And for a 6-lane bridge with a multi-cell box is required. It's not possible to have a single lane, single cell box, but it can accommodate the width up to 20 to 22 meter. Further, when the lane requirement, the traffic requirement went up to 8 lanes, I think it's not only the longitudinally segmental construction was adopted, but also the engineer is very smart. Always, all of us engineers are very smart. We decided to do the transverse segmental construction also. It was divided into a spine and wing construction. As you can see here, first the spine was done, and this is the spine which has been done. The spine segments as well as the wing segments, as you can see here, are precast separately. The erection of the spine unit is done. The wing segments are brought to the location of the site itself, and after that it is transversely pre-stressed. So it is not only the longitudinal segmental construction, it's also the transverse segmental construction was adopted. For this, when we had the deck width of 34 to 36 meter to cater for the 8-lane single girder bridge, which is supported on a single pier, and it was not possible to transport the 34 to 36 meters segment. That's why even in the transverse direction, it was divided into 3 pieces, as you can see here. This is, as you can see here, for the JJ Hospital flyover, first time this segmental construction was precast segmental spine and wing construction was adopted, as you can see here. This was a necessity at that particular point of time. Look at the congestion. Many of the people who are used to Bombay, they know that the Crawford market is one of the very busiest place where the construction was to be done in a Crawford market, as you can see here, which was serpentine kind of profile was to be followed. For that, it was not possible to transport this 16.2 meter segment. That is the reason it was divided into the 3 segments, as you can see here, and that is how it was adopted. In fact, in JJ Hospital flyover, the grade of the concrete was used M75 grade, though the design wise, the grade of the concrete of M75 was not required there. In fact, the design requirement was for M50 to M55 grade, but from the long-term durability point of view also, and also to make sure that stresses are not stretched to its limit, M75 grade of concrete was adopted for the superstructure, as you can see here. As the time passes to cater for 8 lane of traffic, as you can see here, the width of the deck went on increasing from 16.2 meter to the 34 meter, and the number of bridges using the spine and wing constructions has been constructed these days all over the country with this kind of width. So there is a, if you really look at it, there is a scale effect, like the bridge which was done only for 16.2 meter, this could have been done easily, irrespective of increasing this up to the 34 meter width. The design standards as well as the design methodology which has been adopted, it did not change, whether it's for the 16.2 meter width or for the 34 meter design codes, as well as the design methodology adopted remained same. And that's what I call it as a scale effects. The scale effects are responsible for the many of the failures which has been taking place, whether scale effects during the design for construction or the scale effect because of the construction, casting of the segment, etc. This is because of the scale effects. These failures as far as the mishaps are taking place. What are these scale effects? Scale effect is nothing but enlarging or slendering tried and tested design when the protective cover of experience is overstepped, either to insignificant influences become predominant. What does it mean? When you are designing a small structure, small width or a small width deck, the secondary effects may not be governing the design. As the secondary effects may not be governing the design, as a standard design engineering practice, that secondary effects are neglected because that's not going to have an impact on the design. But as the scale of the structure went on increasing, as it became slimmer, slender, taller, and wider, the secondary effect starts governing the design. The hitherto, the secondary effects, which was not governing the design, it starts governing the design as a designer has become, like too much confident in already time-tested designs for a smaller structure. The same principles of the design, which is adopted even when the secondary effects have started governing the design, I think the structure starts giving rise to the mishaps, and sometimes even the failure happens. What are the secondary, the scale effects which we are talking about? I classify the scale effect into the cantilevering wing, ever increasing cantilevering wings in case of the spine and wing construction. One stage priestessing. Earlier, we used to have 2 stages of the priestessing. Now we are going for 1 stage of priestessing at the full transfer of the priestess, stretching the permissible stresses to its limit. And also at the transfer of the priestesses, especially in the spine and wing construction, load mobilized is only 35%. Further load mobilized of 35%, we are priestessing the segment. We are priestessing the beam for the 100% load, which is going to come later, which is 65% going to come later. So the segment is, or the span is stretched to its limits when the 1 stage priestessing is done. And also as the width of the segments or the width of the section goes on increasing, that becomes vulnerable to transverse deformability. When the segment's width is only 16 meter and the spine width is quite comparatively lesser, I think that the segment which was assumed to be rigid in the transfer direction, the same rigidity has been assumed even for a very wide segment, and that may not be valid anymore. For that design assumption may not be valid anymore. And also as the width goes on increasing in the transverse direction, segment becomes slender, and it is vulnerable to bow effect, which I'm going to explain that happens. Earlier, the epoxy glue application has to be done only for, say, for example, 6 meter square surface, that the surface cross section of the segment section was around 6 meter square. Now, when the larger segments are there, the section cross section increases to 15 meter square, but the time availability for application of this epoxy glue is only 1 hour, whether it's a 6 meter squares or 15 meter square. Again, it's another scale effect during the curve section, which will affect our, which will make the structure vulnerable to the mishaps, basically. Now, as we can see here now, basically this from a segment of 24 meter, we have gone up to here 34 meter. Here the cantilever wing width was around 9.1 meter. It went to 9.3 meter. As we go on increasing the cantilever length over here of the wing, it's around 10 meter over here. As the cantilever length to that of the spine width is going on increasing, the load mobilized at the time of the priestessing, of full transfer of the priestessing, is going on reducing, only the 35%. What I mean to say is the resisting property of the segment is only the spine. As the cantilever goes on increasing, the resisting property of the spine is comparatively lesser for the loads which has been mobilized at that particular point of time. So always, I think it's better to have the ratio of the cantilever length to that of the spine width as less as possible, to make sure at the time of the full transfer of the priestess, the property contributing to resist that forces is quite high. Now, since this segment, this is one of the ways of like this the installation of the spine beam, as you can see here, it's an underslung construction method has been used. There comes a stage where the spine wing is fully pre-stressed, as you can see here on the right side, and it is self-sustaining for the priestess. At this particular time, it is a full transfer of the priestess. 1 stage priestessing is come, but only the spine beam self-weight has come. all the other weights which has to come, whether it's the wing weight or the superimposed dead load weight or the live load weight, which has to come later. For that, the priestessing has been already done. At this particular stage, this is fully priestess to its limit because of the one stage priestessing which has been adopted. And at that particular point of time, nowadays, I think invariably we have the span to depth ratio for a simply supported, which is made continuous by the deck continuously. We have around 15 to 18. And for a continuous girder itself, we have the span to depth ratio perhaps 20 to 25. That's a normal practice which is adopted. Those people who are designing earlier using the working stress method are aware that if the span to depth ratio of any beam is less than 12, that acts as a short compression member. If it is more than 12, it becomes a slender member. As it goes on increasing, permissible stresses have to be reduced to a large extent. So at this particular point of time, I think we'll have to relate perhaps since the scale effect is there, it is becoming larger and larger, width is becoming larger and larger, and span to depth may not be less than 12, it is increasing. I think perhaps there is a way to look into that and make sure that to come out with the guidelines as to whether we should reduce the permissible stresses if the L/12 ratio is increasing, similar to that of working stress method which we are doing it. Just to demonstrate the point which I made, there is a cross section here which has been done in three transverse segments, spine segment as well as the wing segments, two segments. But here it is separately cast over here, and here it is cast together. All these things have been cast together over here, monolithically cast. For both these cases, at the time of the full transfer of the priestess, if you really look at it, the stresses when the spine and wings are cast separately, the stress is around 16 MPa, whereas when the spine and wing is cast together, the stress is around 11.5 meters. It is not, when it is cast together, it is not stretched to the limits, whereas it is cast when it is not cast together, it is stretched to the limits, as you can see here, because of the one stage priestess at the time of the full transfer of priestess. Normally, it is an understanding that the priestess members are not subjected to the buckling. And why the priestess members are not subjected to the buckling? Because when the priestessing happens, normally the priestessing tendons touches the member surface. When it touches the member surface, as it is subjected to the tension, this cable tries to come back to its original profile. As it comes back to its original profile, member also tries to come back to its original profile, not inducing any buckling. But for any reasons, for that matter, if this cable which is there inside the member is not touching this any surfaces over here, it is like any compression member which is subjected to the buckling. The same principle is adopted here. I come out with a sort of a proposition here. The spine beam which is there, as you can see here, it is fully pre-stressed, and one stage of pre-stressing is there. It is completely subjected to the permissible stresses. It's already consumed its permissible stresses, as you can see here. For that, when it is already stretched to its limit, for any external compression which is going to come on top of this, say for example, there are some forces, compression which is coming because of unscheduled forces or unintended forces, because of our construction methods, because of our scale effects which has been taking place, which comes on top of this. The buckling property of this member is already altered because it's fully stretched to the members. For the additional compression forces which is unscheduled or unintended, the buckling property is altered, and it is very much vulnerable. For a small compression force which is coming later, it is vulnerable to the buckling. So the conception or the understanding and the perception that the priestess concrete member is not subjected to buckling, only it is not subjected to buckling when it's applied, priestessing force is applied as a compression. But an external force comes, it is not priestessing, already priestess member is subjected to the buckling for an altered buckling properties, if you like to really look at it. What are the ways hidden or unscheduled or unintended force which can come on the spine beam? As you can see here, it can come because of the variation in the Priestessing force. Nowadays, Priestessing force, which is initially applied because of the wobble, the losses because of the wobble as well as the friction coefficients may be lesser, and the Priestessing forces may go up to even by 20 to 30%. Losses may be lesser by 20 to 30%, which has been calculated. By way of that, the Priestessing forces can go up. Also, there could be a temperature variation as well as the temperature gradient, which is not taken into consideration during the design, especially during the construction stage. The temperature gradient could be there in the girder, the top girder, as you can see here, as well as the bottom girder. There could be a combination of the temperature gradient, which is inducing the forces into this girder, and also the wind load is also maybe getting uplifting this. Wind load can come also horizontally, as you can see here. Here you can see this is a vertical legs. These vertical legs are put apart, as you can see here. This girder, already installed girder, not the one which is under the installation over here. Already installed girder is subjected to, it is clamped between this middle support, which is on top of this diaphragm unit near, and also the rear trolley. If for any reason rear trolley is already there on top of the installed span, but with having a separate legs like this, when the horizontal wind force comes, there's a possibility that the unintended torsion also being induced into this particular span which is already installed. So there are many ways that the unintended and the unscheduled forces can come to already fully stretched beam, as you can see here. And we have worked out because of the, in some of the cases, because of the variation, variation in the temperature as well as the variation in the Priestessing forces, this could be an additional forces of around 5.62 MPa. And if it is already designed for stretch to the limits, and because of the variation, if 5.62 MPa is added, I think it's this is going to exceed the permissible stresses during the service stage, basically. And also during one of the stages of the kinematics of the erection, as you can see here in this particular slide over here, and when the erection of the segment goes on here, and it has to be stressed so that this span which is under the installation becomes the self-sustaining by the Priestessing, and there is a possibility when the Priestessing of this span takes place, which is hung by the launching girder, overhead launching girder here, which is connected to this Priestess girder as well as the launching girder by rigid suspenders, which you can see over here. If the deflection of this girder is less than the deflection of this the launching girder, because of the rigid, it is connected by the rigidity, while transfer of the load from launching girder to this bearings, which is over here, there is a possibility of this span being subjected to the additional compressive force. There could be a additional compressive fiber stress at the bottom, and maybe because of this additional force, there's a possibility of this segment opening out at the top. When this segment opens at the top, further redistribution of the compressive forces takes place, similar to that when you're designing a foundation on a rock. Normally, when the tension is there, you redistribute the forces, and it is subjected to the additional bearing pressures. Similarly, that sort of situation happens over here, which is not expected. So these are some of the unintended, unscheduled forces which can come during the erection of this span, and already stretched the spine beam because of the one stage transfer of the Priestess is fully stretched to its limit, and it is also subjected to the vulnerable to the buckling, and all these unintended forces can cause the mishaps. So the designer has to be very careful about it. Another unintended, unscheduled forces could be, normally in the design, what we do is we assume this transversely, this section is rigid for the vertical component of the Priestessing, which when the vertical component of the Priestessing at around 1/4 to 1/3 location, as you can see here, these cables are taking a deviation, and these cables are in the 3 webs, say for example, and these cables are taking a deviation. As you can see here, this is at the deviation point, and this is going upward at the anchorages points, as you can see on this in the both cases. Not only that, when there are two things is happening over here at the 1/3 or the 1/4 the section over here, and we are assuming all these cables are vertically deviation. Because of the vertical deviation, there's a vertical component of the priestessing force over here. This vertical component of the priestessing we assume to be uniformly distributed between these three webs while doing the design. That may not be the case. The central web may be deforming more than the external web, causing the cracks at the bottom, which may lead to the during the priestessing, which may lead to the problems later. And also have a look at it. See here, this taking a vertical deviation over here. The self-weight span moment is around here much lesser than the self-weight span moment at the mid-span, as you can see here. But the priestessing forces is almost the same. So the residual priestessing moment over here is quite a lot, and all the things are happening at the 1/3 or 1/4 section. All unintended things, unintended scheduled forces, unintended or unscheduled forces are seem to be taking place at this 1/3 or 1/4 section, and that could be the reason most of the times what we see the failure takes place. Just to make the point again, have a look at the failure in the work which had taken place earlier. If you really look at it, the trigger of the failure is at 1/3 or the 1/4, as you can see here. And these all cumulative effects could be causing. All these cumulative effects are because of the scale effects, what I was talking about. It's because indiscriminately the width of the segments are going on increasing, but the design philosophy has been adopted is similar to that of the earlier design philosophy, which used to be applied for the smaller section. So again, just to recapitulate that the segment has failed around 1/3 to 1/4. It's not even 1/4. I think perhaps less than that. That's where the failure has taken place. This is where the trigger of the point has taken place. It is because of the scale effects, in my opinion. Also, the scale effects happen because of during the segment casting as well as the handling. That is why we require a special concrete mixers as the width of the segment, as the size of the segment goes on increasing. The design mix should be set that it reduces the heat of hydration, it reduces the drying shrinkage. Perhaps it's very necessary for us to use the abundant mineral admixtures like fly ash as well as the GGBFS, which reduces the heat of hydration and also the drying shrinkage. These are all heat of hydration as well as the drying shrinkages causes the shrinkage cracks during the casting. That has to be made sure that that doesn't take place. And also, as the segment size becomes larger, we'll have to really take care of the pouring sequence so that the cold joints as well as the honeycombing doesn't take place. And the vibration of the concrete is also important. And the casting machine is used in the match casting or a long line method of casting. I'm going to come over there. The shutter vibrators are used, whether it's we have to go for some other systems of the vibration, we'll have to say. And also the handling and the stacking of the segments in the stacking yard is also very, very important. Now, what is this bow effect which takes place? This is a segment casting. Normally, the match casting technology is used in the segmental construction. All of you are perhaps aware of this. In the match cast segment, already cast segment is used as a shuttering surface to cast the new segment. This particular segment is used as a match cast segment. This face becomes the shuttering surface, shuttering face for the new cast segment which is going to be cast. And when this new segment is cast, what normally happens is there is a heat of hydration which is developed in this new segment. Because of the heat of hydration, there will be a temperature gradient, as you can see here, will get induced into the old segment which is cast, the match cast segment which is cast. Because of this temperature gradient, this if this segment, particular segment in the casting yard, if this length to width ratio is more than, say, for example, 6 to 7, normally what happens is because of the heat of hydration induced the temperature gradient, that it becomes a curve a surface like that. And when this segment, newly cast segment, hardens and hardens, this will harden with a permanent curvature set in the segment itself, as you can see here. And when it is separated out, the old segment or the match cast segment regains its original position because of the ambient temperatures it has gone into. But the newly cast segment, which is already hardened with the curvature, will have a set in delta deflection in the plan, as you can see here. This is we had calculated in one of the cases where around 24 segments were there. The match cast was to be done. As we go on doing it for a 0.8 degree of temperature gradient, as you can see here, 0.5 mm deflection takes place in the newly cast segment. The cumulative effect for all 24 segments could be as long as 12 mm. And that, when it's in the casting yard, when it is being installed and Priestess, when we try to Priestess it and to regain this 12 mm back to its original position, there's a possibility of cracking, as you can see here. Another scale effect during the construction is, I told you that as the segments becomes larger, which was in the case of JJ Hospital flyover, the spine surface area was around 6 meters square. And if you take these days, where the segment width is around 34 meter, the segment surface area becomes around 15 to 16 meters square. But this application of the epoxy for the epoxy glued joints has to be done with the same time, 45 minutes to 1 hour you get for the application of the epoxy. It has to be flat, require around 40 labors if it's around 16 meters square. The height of the segment is also increased from 2 meters to, say, for example, 2.85 meter. You will have to have an arrangement inside the segment with the ladders and other things, so that the people can go and apply this epoxy glued application over here. This scale effect also may result in improper application of the epoxy glues, and this epoxy glues, when it hardens, may not have been having a perfect matte perfectly fitting segments with each other. It may be acting as a stream, leading to the compression concentration of the stresses and leading to the mishap. That possibility is also there. Again, it's a scale effect because of the casting of the segments. Now I'll come to this various construction methods, and I don't want to get into the depth of that, but all of you are aware of that. There are there are two principal ways of doing the Precursor segmental construction. One is the span by span method of construction. Normally, the failures have been taking place in the span by span method of construction. That's the reason I have confined my presentation only to the span by span method of construction. And the other is the cantilever method of construction. It's a cantilever. You can be having a various segment shapes, as I explained you earlier. And there are a lot of design methods, decisions, including the method of construction. It depends upon the shape of the segments, weight of the precast elements, arrangement of the priestessing cables, whether it's an external priestessing or an internal priestessing, it depends upon that. And the process of the construction is match casting. Is match casting of the segments. There could be a long line match casting or a short line match casting. The whole principle of the match casting is to make sure the segments are cast so that both the segments are perfectly fitting with each other. That is why one side of the segment which is already cast uses as a shuttering for the casting of the new segment. And the another process is transportation, handling, and the precast segment erection by cranes, gantries, trailers on land, and by water. And erection also, there are three types of erections. One is the underslung launching system, and underslung launching system, and the other is the overhead launching system, and combination of the above. I'll come to that. This I have already explained that the spine, the entire deck is divided into the three segments. One is the spine segment, spine unit, and the others are the wing units, as you can call it, which has been brought to the location and transferred to Priestess. In case of strutted segments, we have the struts, as you can see here. Struts could be inside also over here. The struts are already precast, put it to the casting machine. It's a casting machine over here. And again, the precasting of the segment takes place. This here, double time the precasting takes place. This methodology of the casting, match casting as well as the the long line match casting as well as the short line match casting. I'm not going to the depth, but I'm going to talk about this casting in terms of in the context of the failure which has been taking place only. When the segments are cast, it has to be stacked properly, and always the stacking has to be done. 3 points the support has to be done. For any reason, if there is a 4-point support or a 5-6-point support, the normally there's all the unstable support. It's not a deterministic, indeterminate support. They're all indeterminate support. That's why it has to be made sure, even if the stacking is done in the 2-tier or 3-tier, always the 3-point supports have been ensured. Even while transporting the segment on the trailers, as you can see here, the supports have to be a 3-point segments. If it is not a 3-point segment, be assured there will be cracks in the segment, because when it is being transported, normally it is subjected to a lot of undulations and a lot of change in the axes and kind of thing, because it has to sometimes negotiate the curve. When it is negotiate the curve, it may be having a super elevation there, and the axis itself is changing, and it's also subjected to the vertical vibrations while transporting. That's why if the 3-point determinate supports are not given, if it is a 4-point support, the supports, one of the support cannot be active. It's like having, if you have got a if you are sitting on a chair, it has a 4 legs. Normally, sometimes you see that one of the leg may not be touching. That's why you keep on putting some padding under one of the legs. That sort of situation, if it is there is a problem. To make sure to have a deterministic support, normally we have 3-point supports. Also, always while handling the segments, we'll have to use the spreader whip. If it's only use the slings, that's a possibility of imbalanced force transmission to the segments through this slings. That we'll have to make sure that the spreader beam is used. There are instances where the spreader beams are not used while lifting the segments, either in the casting yard or in the while erection, thereby leading to the number of cracks in the segments. To avoid that, this crack itself may become a problematic and result in mishaps as well as the collapse later. So we'll have to be careful here, even in the casting yard. I'll come to this quality control. It's very, very important again. As we have seen here, this is one of the match casting, short line match casting machine over here. You see here that the concrete has to be flowing inside this narrow shuttering space between this shuttering, 2 shuttering places. The inner shuttering, inner core shuttering, it's the outer core shuttering over here. And here there's no bottom shuttering is there. On top of the concreting will be done. And this is where, just to show, the concreting has to be done in this spaces. And also the concreting has to be done, has to flow to the each and every nook and corner of this casting machine without any honeycombing, without any construction joint. And once the concreting is done, it has to be vibrated properly. Since this casting machine is going to be used for the number of repetition, it is always made sturdy. When it is made sturdy and subjected to the shuttering vibration, I'm not sure to what extent vibration is effective there. But if the self-compacting concrete is not used for the construction of segments, the casting of the segments, we'll have to be very careful to make sure the mix design is such that it flows each and every corner of the segments which has been cast over here. You'll have to have a definite the sporing sequence to make sure the construction joint, hole joints doesn't take place. And also you'll have to have a vibration system so that the vibration is very, very effective and the concrete consistency is maintained. That needs to be really. So it's a holistic approach of casting of the segment. If the casting of the segment doesn't take place properly, it gives rise to the shrinkages and also gives rise to the honeycombing, etc. There will be a problem. Also, normally, invariably, the cages are prefabricated and put into the molds. And within the casting machine, as you can see here, it's not possible. It should not be done. The fixing of the cages or the fixing of the reinforcement should not be done, because it creates a problem to the casting machine. This casting machine may not be lasting for a long time if you do that. That's why this you have to make sure the prefabrication of these cages are done very close to this casting machine, and transportation is done always using the cranes as well as the spreader beam. As you can see here, we should not use a trailer for transportation of this prefabricated cages. If you use this trailer, you be rest assured that it will be subjected to deformation, and the reinforcement of the cages will not be in its original places. So it has to be planned properly. There are some cases, if the mixed design is not proper, vibration is not proper, sporing sequence is not properly planned, there could be honeycombing, as you can see here, grout leakage due to formwork can be there, lack of concrete compaction can lead to this bleeding, as you can see here, and there could be a formation of the cold joint. All has to be avoided. Precast segment is a very, very important segment because it's going to be post-tension later. When it is going to be post-tension later, and it is subjected to the highest compressive forces. So any kind of this kind of deficiencies in the segment are going to create a problem during the construction, and it has happened. Bow effects I've already explained to you. If there is a cumulative bow effect in the match cast segment, because it's for the very wide segment and the very slender segment, where the length to depth, length to width ratio is more than 6, there could be, these segments are, if they are during the erections, are forced to pre-stressing, and if you try to pre-stress that to gain its original position, there's a possibility of the cracks, vertical cracks in the segments, as you can see here, and this crack itself may lead to the mishaps later. So we'll have to be very careful about it. Then coming to the erection and the quality control during the erection. See, as you are all aware, it's a sort of a, the metro construction has become some sort of a cottage industry now. You see that 3 types of erection. One is the falsework erections, as you can see here. The precast segments are brought to the location and erected on top of the falsework or the staging, as you can see here. Overhead launching system, it's all seen quite extensively used in the elevated corridor these days, as well as the metro construction. And also there's a underslung launching system in combination with what we call it as a camel gantry or a segment feeder, which can be also called as a segment feeder, as you can see here. These are some of the photographs of using the scaffolding as well as the pressure system. These are the underslung systems. In the underslung system, you've got an underslung girder, which is supported on a temporary brackets, as you can see here. Sometimes it can be supported on a pile cap or a well cap, as we have done in a couple of cases earlier. And this, on top of this underslung girder, the segment will be put on top of this underslung girder, as you can see here. And this is brought to using the trailer, as you can see here. This segment, which has been brought by the trailer, can be seen, and this segment will be handled by the segment, what we call it as a segment feeder, and this will be having an arrangement so that the segment can be lifted up, brought to this cantilever, and here it will be having a swiveling arrangement, and transversely it can be swiveled and put on top of the trolley, which is there on top of the underslung girder over here. That sort of system will be there. The similar systems, the variation of the similar system you can see on the left-hand side. These are all sophisticated systems which can be used. Overhead launching system I explained to you, and it will be having it will be moving on top of already installed the box girder or the girder. Sometimes, as you can see here, there are number of variations of the overhead launching system. Overhead launching system can also be used for the erection of the U-troughs, as you can see here, which has been extensively used nowadays for even the metro construction. I've explained unhidden or the unintended scheduled force, unscheduled force, which you can come here. The overhead, using the overhead launching system, the erections of the segment is going on, as you can see here. This is a stage where the transfer of the priestess takes place to make this the deck, which is under the installation, by application of the post tensioning here. While application of the post tensioning, we'll have to make sure by operation, this is normally kept on the temporary jacks here. By the operation of the temporary jacks and also the release of the suspenders, rigid suspender, you'll have to make sure that the unintended force is not getting induced into this the deck which is under the installation, and which may create problems later. Similarly, the unintended, the unscheduled force, what I called, can come for the underslung erection system also. Here it was an overhead erection system, as you can see here. Similarly, here also it can come, and the already installed girder, like when it is Priestess over here, this particular girder is Priestess, it hawks up. When it hawks up, the launching girder tries to regain its original position, and if the launching girder is not deflecting similar to that of the girder which is under the prestation, there is a possibility of additional compression which is induced at the bottom fiber of this girder which is under the installation. You'll have to make sure that doesn't happen. Otherwise, because of this kind of thing, there is a possibility of unscheduled, unintended forces which is not considered in the design, which may lead to the problems later. Then also it's very, very important for us to see look at the bearing installation aspects. Bearing installation, we have to make sure that during the installation of the bearings, that the proper mortar pads have been provided with the shrink-free mortar under the top plate as well as the bottom plate. And also you'll have to make sure the horizontal orientation and the performance assurance, like this, the bearings have to be placed in such a way that the top surface of the girder as well as the pedestal, the bearings have been sandwiched in between, and both the surfaces have to be horizontal to each other. To achieve that, you will have to provide some sort of a wedge in the top plate or in the wedge in the concrete segment itself by way of providing the slope here. So this bearing is sandwiched between this top wedge as well as the bottom pedestal, as you can see here. This surface should be horizontal. It should never be installed in an inclined manner, as you can see here. If it is installed in an inclined manner, there's a possibility of this girder which is under the erection being unstable. So that has to be completely avoided. And also the bearing have to be given preset. Sometimes it is given, and whatever the preset which has been given, normally the bearing suppliers provide a temporary lock. That the temporary lock is to make sure how the bearings has to be at what position and by what configuration it has to be placed, and only while activating the bearings, then only this temporary locks have to be removed, and the temporary locks have to be removed under the certain temperature, that has to be which has been prescribed by the bearing manufacturers. And there will be a guided bearings nowadays, and we'll have to make sure the bearings are placed in its proper location. If the bearings are not placed in the proper location, if the longitudinally guided bearings are placed in the transverse guided bearing location, where the pin joints has to be there, or the fixed bearings are there. If you put in the longitudinal bearings, there's a possibility of failures which has been taking place. It has happened quite often. You can see here. Here is one of the cases, curved spans, where perhaps where the uplift bearings have been provided, there the uplift bearings was not provided. It was provided in the long position. Thereby the failures might be taking place. If the girder, here is a case where the grouting is not done properly. And if the grouting is not done properly, your bearing is going to fail. That's for sure. And the wedge, what I was talking about, to make sure that the horizontal the bearing is sandwiched between the two horizontal faces. The wedge can be also provided by a top plate, as you can see here. And also it's very necessary to plan this top plate as well as the bottom plate bearing studs, which is going to be inserted into the sleeves, which is going to be in the segments or the pedestal below over here. The spacing of the stud should be such that it should be possible for us to insert the reinforcement over here, so that the congestion of the reinforcement doesn't take place and the concreting is possible. Many cases I've seen that it's not possible, the studs are so close by, it's not possible to insert the reinforcement which is necessary to be inserted here. As if the reinforcements are cut or the necessary reinforcement are not provided, it is a sure recipe for the failure later of the superstructure. These days, I have seen some of the cases where the people are using, say the deck continuity in the stiff, the deck continuity only in the deck slab continuity. In the deck slab continuity, normally what is done is the two decks are connected by a deck slab continuity on top. The girder itself is not continued properly. When the two, that means the girders are simply supported first, and these two girders are simply supported first. After doing this two girders, simply supported girders, normally you have got a deck slab over top of the spears. This deck slab continuity is established. That sort of situation, that sort of construction is preferred because it's easy to design, as well as the construction span by span method of construction by this way of doing is also easier. Nothing wrong in that. But in this kind of this one, suppose you consider one module of a continuous module, as you can see here. This could be a fixed bearing over here, has to be there, and there has to be a free bearing, and there is an expansion joint here. When you have got a free bearings, a fixed bearing on a fixed pier, you have to make sure if one row of the fixed bearing longitudinal fixity is there in the one row, you will have to make sure the other row has to be longitudinally guided. There are instances which I'm coming across in many of the places the designers have provided both the fixed bearing. When both the fixed bearings is provided, how it is going to be deck continuities, when the deck continuity is established, when both the fixed bearing is there, because of time dependent, the expansion which can take place in the deck slab will induce an amount, the large compression forces on this bearings, and the bearings may fail, and this kind of practices has to be stopped immediately. And also when this kind of deck slab continuity is there, always the simply supported girders are cast, and here is a case where you have a simply supported girder of 30-meter span, and that is resting on that. Here the deck slab continuity is not established there. When the deck slab continuity is not established in this span, you have a look at it here. Here is a free bearings, longitudinally free bearings, both at this location as well as this location. It is a floating span. It is not subjected to any locking. Under such circumstances, it has to make sure this particular span, which is floating, which has a longitudinal bearing here, guided bearing here, as well as the longitudinal guiding bearing here, is locked till the deck slab continuity is established. And there are many of the people, it happens that the spans are not locked, as such the collapse of the structure takes place, as you can see here. If for any reason, if there is a workman working over here, workman will not understand this kind of simple situations, and for any reason there is a horizontal force, this floating span is going to be slipped off the pier, and it's going to fall down, as it happened in this particular case. So we'll have to be careful about the bearing arrangement and also the deck continuity system. There has to be a very, very categorical method statement stating that this, when till the deck continuity is established, especially for this kind of the floating slab, floating spans, the locking arrangement has to be there, and there has to be a special drawings of the sequence of construction drawing, and it has to be made very, very clear to the contractor. If it is not made clear to the contractor, contractor will understand that this is a temporary lock which has been provided, is the locking arrangement which has been provided. He will argue that this is a locking arrangement. I thought that is the reason I had not done any extra additional the locking arrangement for this. As such, like I have taken care of whatever is there in that particular drawing. So it's necessary to have a sequence of construction of drawing very well explained by the designer to the translator at the site. Then what is this precast segmental construction? It's all about the joints as well as the post tensioning. Once the precast segments are cast, they are jointed together, they are post tensioned together. And there are different kinds of joints, as you can see here. There could be a joint, a cast in situ joint. If the cast in situ joint is more than between the two segments, more than around, say, for example, 200 mm, you may have to provide the reinforcement. Up to 150 mm, it may not be necessary to provide the reinforcement, but to that, you may have to have a fast setting, shrink-free concrete, which has to be done there. You can also have a dry joint between the two segments. The dry joint, in the sense, where the epoxy application is not required. Without the epoxy application, you can have the joints. Normally in the joints, the detailing has to be done, as you can see here. The joints, the detailing is similar to that of any RCC detailing. Here says shear keys. Within the shear keys, you have to have a reinforcement at the edge, as you can see here. That is how the joint is done. And it's possible to have the dry joints. Normally the dry joints are avoided whenever the internal priestessing is done. In the internal priestessing, the cables go from one segment to another segment, as you can see here. When the cables go from one segment to another segment, these cables, to protect these tendons, the epoxy joints are required. The epoxy joints will be normally provide the another layer of protection. Basically, that is why epoxy joint is done. But if you are not having an internal priestessing, but you are going for an external priestessing, the cables are not going inside the concrete, the protection is not required. And also in the joint, there's a sufficient cover, the dry joint itself is enough. When the external joints, external priestessing is taking place, the epoxy glue joints may not be required. So there is a detailed guidelines given by Indian code makers, that's SP65, which gives how to make the epoxy jointed surfaces, and it gives the elaborate detailed explanation as to how it is to be done. In India, the epoxy joints is preferred because the external priestessing is not encouraged much, and also the epoxy application, it's some sort of a psychological advantage we have, that whenever the surfaces are not perfectly not matching, the epoxy goes and occupies the crevices. Even when the shear keys are broken, epoxy can be filled up over there, and also it acts as a lubrication when the jointing, the jointing between the two surfaces is done. And as in the case of the internal priestessing, it gives the extra protection cover to the cables so that the aggressive ions are not penetrated, initiating the corrosion. The water ingress into the cable, post-tensioning duct doesn't take place, and the initiation of the corrosion doesn't take place. That it gives an extra protection layer. That is why the epoxy glue joints are preferred in India. I told you that these are the very detailed specification is available, so special publication is available as to how to apply the epoxy. That has to be followed in Indian situation. This is some the application of the epoxy I have just shown over here. This is the underslung launching girder system. The segments are brought, as you can see here. They are dry jointed first. After having dry jointed, and make sure the segments are separated out. After that, the application of the epoxy takes place. It's manually applied. Of course, this is not a good photograph because the safety is not followed over here. Safety shoes are not worn. Then the temporary priestessing will be done using the temporary priestessing devices which has been provided in the segments. The temporary priestessing is done by PT bars, basically provided, and by threading that. The temporary priestessing is done in such a way that the epoxy oozes out, and oozed out epoxy has to be swabbed perfectly so that this epoxy doesn't get into this post-tensioning ducts, which may create problems later, and also it doesn't fall down. And it has to be made sure that the temporary priestessing is applied both as well as the top as well as in bottom, in such a way that the application of this epoxy, application of 0.3 MPa pressure is uniform across the section, whether it's from top to bottom or from the left to right in a transverse direction. If the application of the epoxy pressure is not uniform, there is a slanted surface formation over there, which may have to be corrected in the subsequent segment erection by way of provision of what we call it as a shims. That shims has to be of that of GRPF shim. You should not use the steel plate, as the GRPF has the same the elastic modulus property of that of the hardened epoxy, so that the properties are compatible with each other. If you are using the steel plates for the correction of the geometry, I think there's a possibility of the concentration of the stressors that needs to be taken care of. So I just have given you here an example of say for example, 10-kilometer elevator structure is going on with the 40-meter span. The 40-meter span will be having say 12 segments. There will be 13 joints. These 13 joints have to be, each joint, the application of the epoxy will be taking around 1 hour using the method which I explained earlier. And after the application of the epoxy, the pressure of 0.3 MPa has to be maintained for 24 hours as per the SP65. So the 37 hours are required in total for 40-meter span for the application of the epoxy. And for the 10-kilometer, the application of the epoxy requires around 385 days, almost more than a year. And also the epoxy cost, which is required for the 10 kilometers, around 5 crore rupees. And see, there are so many problems as far as the epoxy application is concerned. Epoxy has to be applied within 1 hour. That is very difficult to apply it within 1 hour. And also it is costing 5 crore rupees more, and it's time consuming of 385 days additionally. And the only purpose of the epoxy to make sure that the internal pre-stressing which has been provided is safe. It is not subjected to the initiation of the corrosion by ingression of the water, right? So I see as a sustainable solution going forward, external pre-stressing with the dry joints. That will save the time as well as the money. And also the epoxy is not an environmental friendly product. From the sustainability point of view also, it is not good. I suggest going forward the external pre-stressing for the span by span method of construction using the dry joints. Special, I'll just come to this a final. I think there could be, depending upon the ease of the construction which the contractors prefers, you can have the different PT layout. As you can see here, there could be a girder continuity, and the pre-stressing could be there in the diaphragm, as you can see here, which is crossing with each other, crisscrossing each other. And also the diaphragm can be pre-stressed having a separate, without having a crisscrossing arrangement of the one span to the another. You can also have the separate pre-stressing tendons over here, as you can see here. And the simply supported made continuous by the deck continuity also can be had. That's the easiest way of doing the continuous box girder construction that has been followed in India. And also you can have a span plus 1/4 the span, where perhaps this the coupling of the pre-stressing cables are required. By using the coupling of the pre-stressing cables are required. Nowadays this sort of construction, this PT layout, is not preferred much. I told you about the external as well as the internal pre-stressing. I prefer external pre-stressing with the dry joint instead of the internal pre-stressing with the epoxy glued joint. From the sustainability point of view, that point I already made. I'm just giving here a case where normally those people who are involved in the design of pre-stressed concrete construction, they are aware that you'll have to work out the immediate losses. That's the friction as well as the wobble coefficient. And for the different HDPs, I think perhaps if you really look at it, the friction coefficient, the wobble coefficient was around 0.0046. When it was really tested, wobble coefficient is 0.0019. So the losses which has been calculated theoretically will be much higher than actually which is happening. Even if you look at the friction coefficient 0.0818, besides the friction coefficient of 0.25, it's 1/10, almost 1/10 the losses in case of the friction coefficient. So there is a possibility of always at the one stage transfer of pre-stress, at the full transfer of the pre-stress, the immediate losses which has been calculated may be much lesser than what has been calculated theoretically, thereby 10 to 20% of increase of the pre-stressing forces, giving rise to the higher compressive stresses in the girder. And that is the reason it's perhaps necessary to establish the friction as well as the wobble coefficient by the testing, necessary to by testing to exactly calculate the friction as well as the wobble losses. Good workmanship at the location of the joints. In the match casting, there is a possibility of the duct being lower or the sagging. As you can see here, we'll have to secure it in such a way that this sort of sagging doesn't take place. And also when the web concreting is going on, when the concrete is moving in the transverse direction, there is a possibility of this cable ducts, the post tension ducts being within the segments moving inwards, as you can see here. All this will create problems during the actual priestessing, inducing the forces which is not intended during the in the design calculations. Basically, near the blister, you will have to make sure that is held into the position. Proper detailing has to be given uniformly. Reinforcement has to be given so that this reinforcement takes care of the radial forces over there. I always prefer this curvature part near the blister always has to be within the bottom, within the deck portions, as you can see here. And also in case of when the external priestessing, where the blisters are provided as a deviator blocks, we'll have to make sure the bends, the steel bends perfectly, has been provided so that the external exit angle of the cables which is coming is not forming the kink later. This has to be fabricated properly. This has to be provided in the deviator blocks. To make sure that during the construction, the ducts which has been provided in the segments during the concreting is not getting punctured, you can also use the inflatable hoses temporarily inside this ducts, as you can see here. And also sometimes we also use this HDP sheet duct within the duct which has been provided to as a shuttering, so that the ducts which has been provided will not get hampered or subjected to the damages during the concreting and the vibration. You have to make sure that after the segment which has been cast later is make the leak proof for the ingression of epoxy glue as well as the water later during the service condition also. For that, normally what is done is a steel sort of a band is put in over here to make a groove over there, and when it is the next segment has to be cast, a rubber band of the twice the depth of the steel which has been provided, steel groove which has been provided is given, and the segment is cast, and during the temporary priestessing is done during the erection, so that the leak proofness is achieved. And also the different proprietary system is also available to make sure that ducts between the segment joints are leak proof. This is one of the proprietary the couplers which has been used by VSL, and every manufacturers of the sheathing duct as well as the priestessing systems supplier has its own proprietary system. Finally, the rest of the post tensioning as well as the grouting is done as usually for the regular priestess concrete structures. There are some very good references are available for post tensioning, tendril installation and grouting manual by FHWA, and also the FIB Bulletin 33. I suggest this should be referred to by all the participants today. Durability of post tensioning tender. FI Bulletin 20, even though it's a very old document, it is a very, very good reference for the grouting of tendons in the priestess concrete. The latest bulletin, the FIB 75, also can be referred to for the polymer duct system for internal bonded post tension. And with this, I have come to the end of my presentation. I thank the organizers for giving me an opportunity to give a Dr. Ramakrishna Endowment lecture. I'm really honored and privileged. If anybody wants to ask questions, I'm at your disposal. Thank you very much.
Yeah. Friends, that was Dr. A. Ramakrishna's 9th Endowment lecture by V.N. Hegde. In fact, understanding design and drawings, the casting of segments, including handling, stacking and transportation, then quality control, erection of segments, joints, temporary priestessing, post-tensioning, grouting aspects, all in one lecture. Sir, you have covered the entire topic in such a minimum time, and to how to avoid the failures and collapses of basically the precast segmental bridges during the construction. Friends, before I really open up for the discussion, there is one question from the participant which I would take up first, and then we will open for that. Sir, in the construction of multi-span precast concrete segmental bridges, in-situ stitches are often cast in connect together, and since these stitches are often lightly reinforced, the robustness of the segmental bridge could be adversely affected by the capability of the stitches to resist the large variations in the moments during the extreme events. So how to overcome such problems, and with your experience, what evaluations are recommended for the robustness especially?
No. See, normally in the precast segmental construction, near the span, near the pier, we have a very small cast in situ unit. In India, the cast in situ portion is not more than 100 mm. In abroad, it is more than 100 mm also. If it is only up to 100 mm, we have got a special mix design for that. In fact, I think pre-mixed concrete is also available. Pre-mixed concrete is also available. It sets very fast, and once it is setting, I think it gives a very good concrete over there. It is not necessary to worry about this long-term robustness as well as this, because this stitch concrete, cast in situ stitch concrete, is going to be pre-stressed. After the, it is not going to be just left like that. After the cast in situ pre-stress stitch concrete is put over there, it is going to be pre-stressed and it becomes a part of the entire span. So there should not be any worry as far as the robustness of this stitch concrete, because it's impossible to perfectly cast the segment. Normally, this stitch concrete portion of 100 mm is provided for the adjustments. If there is any error, sometimes what happens in the casting and all, to overcome this error, the small stitch concrete is provided. I think you should have that. And if it is not more than 100 mm, I don't think it's necessary for you to provide the reinforcement over there. And if you are not providing the reinforcement also, it is going to be concrete, is going to be pre-stressed over there. And when it is completely pre-stressed, it's not, in the pre-stressed concrete construction, the tension is not allowed, especially under the serviceability limit state, service condition. So I think it's always under the compression. I should not worry about it. It's not any problem.
It was a really good answer. So in fact, we have Pan India presents today. We have Dr. Harshvardhan Subbarao, and we loved AR actually. In fact, Mr. Girish from Bangalore he joined. We always say that in building construction there should be some kind of a collaboration, coordination, and integration. Civil engineers' role is very important. But when it comes to the infrastructure development, basically in the bridges and all, when we see the failures of the bridges before construction itself, because a common man, when they come to us, and so we are little very challenging to even answer. So how this collaboration and coordination is required? If anybody wants to talk or have some points here, I think Mr. Girish or Harshvardhan Subbarao, can we have some word from you? Mr. Girish.
I'm sorry, Dr. Anchuri, can you come again, please? I just lost you on the last point.
See, actually what we say in the building construction, we have a team of people, those who are responsible for the failures of the structures. And as we always face the problem of giving the answers, but in infrastructure, when it comes to the failures, so where all civil engineers are involved. So how to have that challenge? What really we have to come and collaborate? That was the say.
Sir, basically, the main purpose of what that task entailed has to be very clearly recognized. And then for that main purpose, what are the critical ingredients and the secondary ingredients of tasks? So that is how we meticulously go through with a fine-tooth comb in order to ascertain the cause of the failure. Many times the cause of the failure are what Mr. V.N. Hegde very rightly said, which may seem very superficial, but it will be highly critical. For example, in one of the building collapses, when we did a forensic investigation, we realized that the reinforcement ties or the stirrups had only 90-degree hooks and not 135-degree hooks.
Yeah.
So normally on the side, people think that what is the difference between 90 and 135-degree? But then when we showed them the photograph, the 90-degree hooks, were just, it had come out. And we went further and challenged our own question to ask whether it is really so. But then we found a series of failures with strikingly similar, situations and images. So when we did that, as you rightly said, that we should go into the nitty-gritties when we go into the investigations to find out. Now we have to backwork and incorporate that into designs very clearly. And most importantly, when you execute the last man, like Dr. Hegde said, that when you apply epoxy, you need to make sure that the entire surface, there is an epoxy. Because who is the person who is going to go up there and see that? It is left to the person who has applied. Perhaps even the supervisor will not see that. Absolutely. So that integrity has to be there. And it's a holistic approach. You have to motivate that laborer. You have to motivate just by not telling that I'm going to give you something extra. You have to say that the lives of millions of people depend on you. So that sense of respect and responsibility has to be inbuilt, which unfortunately in the Indian, or rather in the construction sector, they think that this is not that important. So the pride of work that person undertakes should be inbuilt in him so that he ensures that the application of that particular epoxy is throughout. So I'm just taking a very small fraction of a detail, sir. There's so many other things. So I think right from design, execution, especially every stage, you have to have a hawk's eye and it has to be a textbook finish. It cannot be optional. And then when you execute completely, we should also ensure that there is a team which does not report to the project team, and that team undertakes the final QA assurance. Yes. I think that's the answer.
Mr. Hegde, we wanted to give the 2-3 minutes gap for you because 1.5 hours non-stop you spoke. We have Dr. Pradeep Kumar Ramacharla, who is the registrar of IIIT. Normally, when the academicians come, when the failure occurs, I think, Dr. Pradeep, what is your say? Because Dr. A.R. entirely struggled for the betterment of the society in terms of the infrastructure and all. What is your, as an academician, what exactly you would like to supplement on this day? Dr. Pradeep.
Yeah, Dr. Anchari, actually I'm outside. I'm not able to put on my video.
Okay.
So, yeah.
Your voice is good enough.
I really enjoyed the lecture, sir. It was really excellent lecture. Now, when it comes to like these segmental bridges, there are a lot of advantages. I would like to point out one important thing, that is in near fault region, this vertical acceleration is often ignored. So that is the main point. In addition to that, the comment on this 135-degree hook, that is very, very important. So we need to raise the awareness in people who are actually implementing it, who are on the ground, and explain them what are the consequences if they are not doing their job right. And as it is rightly said, it should not be with some extra money or something like that. Extra money can be given, but this responsibility of doing their job right should be inculcated. It was really excellent demonstration, sir, in the lecture.
Sir, actually, you are from the bridges and other infrastructure, but we have people from irrigation and water supply. We hardly hear in public about the failures of those structures. I don't know what exactly goes behind that, but can Dr. I. Satyanarayana Garu add something, or even Shyam Prasad Reddy Garu? Those are the legendary in the water supply and irrigation structures. Any comment from Shyam Prasad Reddy Garu? Shyam Prasad Garu, Leda ISN Garu, before I really open for others. ISN Raju Garu.
Hello.
Yeah, ISN Garu.
Hello. Exactly what exactly you want me to have?
No, sir. Normally we started with the buildings earlier because this is the 9th lecture. Normally we spoke about the bridges, then infrastructure, and in fact, Dr. A.R. was very much involved in all types of infrastructure. So today we talk about bridges, but about irrigation structures and all. Really, what is the scenario of the in case of failures and collapses? How really people work together?
Actually, irrigation structures means there is a composite part of irrigation structure. In dam spillways also, we'll have bridges.
Yes,
so
yes.
There dam is also the same issue will be there. Whatever the learner speaker has done, that will be applicable to irrigation structures. All care can be done, and mostly I think now it is a prefab structures. Now we are using the prefab structures, beams and other things for prefab structures. So, but our portion of this bridge portion is almost will be considered to be a component of about 10%, 90% of the hydraulic structure. But this, whatever today's lecture, that is also useful for the irrigation engineers. Irrigation, everybody is basically civil engineer. So irrigation engineers also, they are involved in bridges also. But nowadays, even the irrigation department also designing the road crossing bridges of 4-lane or 6-lane bridges also by them. And it is a wonderful talk we could able to have from the learner speaker. And thank you very much. Thank you all.
It's great. Any other any comment from the speakers, or if you have any question to Mr. V.N. Hegde, I think you can pose him directly.
If you don't mind, can I just come in, Dr. Anchuri?
Yeah, you go ahead.
Yeah.
Go ahead.
Sir, we are Nagde, sir.
Yes.
No, in fact, you seniors like you are not just experts. You are sort of legends. So you carry tons and decades of experience and expertise. I always keep thinking that because I have also now crossed over 50. Now, all these tons of expertise, how do we impart it on to these youngsters real time? One is we need to have a real apprenticeship program, and then we should also monitor and manage them for at least about 3 to 4 years to 5 years, and then let them go as independent decision makers. So all of us combined together who are above the age of 50, how do we transfer this type of very pertinent, because people like you are not, we don't come often, you are very rare. So we need to transfer that across to the generation so that they don't start and reinvent the wheel.
Yeah, I think that's a very good question, Girish. See, this there are a lot of institutions who have been working in this direction. Actually, see, we have been participating in this. I don't know whether Dr. Harsha is there among the.
Yeah, he was there, but now I'm not finding it.
Among the audience. Now you see, we have been doing this sort of transfer of knowledge, especially what you're talking about on behalf of the Indian Association of Structural Engineers, Indian Institution of Bridge Engineers, and also to a certain extent through this IABSC, in Indian Association of Bridge and Structural Engineers, IABSC. There are people, I will tell you, who are taking a lot of part in the dissemination of knowledge. Now, since you are interested, I will make sure that now I got another person along with me. I will make sure that you will be dragged into this. And there are, IAS, on behalf of the IAS Structure, we have conducted the Priestess concrete courses. On behalf of the IIB, we have conducted the bridge engineering course. That course goes for, each Saturday we have around 5 hours. And it is 5 hours and 5 Saturdays continuously, 5 to 6 Saturdays continuously. Similar course has been planned for the repairs and rehabilitation of the bridges in the future. I know that you are one of the person. Don't worry, now you will be dragged into that. You like it or you will be forced into that. But the idea is correct. I think we'll have to transfer our whatever the knowledge which we have got to our next generation. They will have to take it forward, and we'll have to work towards that. Dissemination of knowledge is very, very important. And I think it's like, you see, I'll tell you what, this in our construction of the bridges, some of the trades like the well sinking and piling and etc. It's a 4 months job. 4 month used to be there, and these trades used to get transferred from one generation to another by the 4 months. Now that sort of trade is waning basically. Similar things should not happen in the engineering also, like as you rightly said, the knowledge which you have got, it has to be disseminated. We'll have to get into this institution and we'll have to participate it. You will be dragged in, be assured now.
In fact, the Institution of Engineers itself is one of the biggest institution in the world. And Mr. Girish, 50 is the youngest in the Institution of Engineers. In fact, you are the youngest. So in fact, you and me are very, very, childs for this. And in fact, we have Engineering Staff College of India, and we have very organs which are extensively working on, because we have about 15 plus streams, and we collaborate like anything, because we have chairman from electronic division, we have EC member from different divisions. We come together every month, we interact, and we have a different strategy other than education, like engineering and even practitioners. I think collective efforts are required. This is one of the in fact, when I was traveling with Dr. A. Ramakrishna just 3 days before he passed away, we were about to launch some program, because for Hyderabad he is very, very close in his heart, because he developed a lot of infrastructure, and in fact he wanted to come as a chief guest for one of our project, IC Indian Concrete Institute program. So we couldn't receive him because he passed away in Delhi on that day. So since then, this is the 9th year we are doing a very, very big program. In fact, we conduct 2 days workshop on his name and then end with this. But due to this pandemic, we thought we should restrict to the webinar, and we had a very, 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 very eminent speaker like Mr. Hegde. So anybody else to speak on, please?
I think there is one Lal Rupoya HMR.
Yeah. You can go ahead, sir.
I think you'll have to allow him. I think he has raised the hand.
No, he can do it, sir. He can open.
I don't think he is coming. Yeah.
Hello.
Yes, sir.
Can you hear me?
Yes.
Yeah. I joined from my mobile handset. So audio, video may not be visible properly.
Yeah.
I'm sorry for that. Still, can you hear me?
Yeah, we can. We can.
Still, I am happy to be part of you. That's all for the time being. I am from Mizoram.
Oh, I see. Very good. Good to hear from Mizoram.
Yeah, thank you for being a part of among of you.
Yeah, thank you. Thank you.
It's great. It's really great. Yeah.
Thanks.
Mr. Venkat Subbaiah, are you there? Please, over to you, please. The Honorary Secretary of Institution of Engineers, Telangana State Center, Mr. Venkat Subbaiah.
Yes, sir. So it is my pleasant duty to perform vote of thanks after an excellent lecture, sir. So respected chief guest and speaker of today's endowment lecture, Engineer V.N. Hegde, former CEO of STUP and former ED of Gaman, Engineer B. Brahma Reddy, FIE Chairman, IEA TSC, Dr. S.P. Anchuri, MIE member, IEA TSCC, and convener of this event, galaxy of eminent personalities, past presidents, past chairmen, council members, committee members of IEA TSC, corporate members of IEI, family members of late Dr. A. Ramakrishna, media friends, ladies and gentlemen, good evening to all. On behalf of the Telangana State Center of IEI and on my own behalf, I convey our sincere and profound thanks to Engineer V.N. Hegde, former CEO of STUP and former ED of Gaman, delivered the Dr. A. Ramakrishna 9th Endowment Lecture on avoidance of collapse of precast segmental bridges during construction. Sir, your lecture is very informative, interesting, and innovative, and excellent presentation, sir. So I once again extend my heartfelt thanks to you, sir.
Thank you very much.
I also thank the dignitaries, past presidents of IEI, past chairman of IEA TSC, past honorary secretaries of IEA TSC, council members, committee members, corporate members, and others who made it convenient to attend this event. I also thank the representatives of media for unstinted support to cover the proceedings of the event. Thanks to one and all. Now I request all of you please raise for national anthem. नायक जय हे विधाता जाब सिंधु गुजरात मराठा उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आश मागे
गाहे
तव
तव
जय गाथा
नायक जय हे भारत भाग्य विधाता जय जय
Thank you.
Thank you very much.
Thank you. Thank you.
Thank you, sir.
Take
Okay.
care. Stay
Thank
safe.
you.
Thank you.
Sure, thank you, sir. Thanks to all of you, sir.
Thank
And
you.
Anchuri, sir, for well conducting this event. Thank you once again, sir.
Thank you.
Thanks a lot. Stay safe. Thank you.
Yeah, thank you, sir. Have a good day, sir.